How much energy is required to fly to the edge of the solar system? Well, let's define the edge first. The edge of the solar system, say 9 billion miles away. The Uranus is like 2.6 billion miles, so it's way beyond the Uranus. There's another belt. We define this as a edge of the solar system. The comet from there accelerates by the sun's gravity. So let's use the comet as an example to see how much energy it takes. So 9 billion miles away, and Earth is only 147 million kilometers away from the sun. Okay, so as you learn in physics, the gravity potential energy is proportional to the reciprocal of distance. So we calculate potential energy difference from here to Earth. Okay, so potential energy difference, plug in the constant, we will get tremendous amount of energy per kilogram. That much energy. Okay, what does it mean is there is a potential energy difference between this and that. When comet come all the way from edge of the solar system and come around Earth, the distance of the Earth about 150 million kilometers away from sun, this potential energy is converted to kinetic energy. That's going to be the speed of the comet. And the comet speed is going to even increase around the sun and shoot it back. So you need tremendous speed to go back to the edge of the solar system. Okay, this potential energy and kinetic energy conversion keep going on for the example of the comet, and that's what we learn in physics. What is the speed of comet from the edge of the solar system? Say comet was not moving, zero speed at the edge of the solar system, and its increased speed gain the kinetic energy. Okay, so we calculate simply kinetic energy equals this potential energy difference. We're talking about Mach 1269. That's the speed around the Earth, and speed increase even more around the sun and shoot it back. Okay, so what happened is this kind of speed on Earth is not attainable by human science right now. The human has a problem. Beside the sun's gravity, first of all, we have to get out of the Earth's gravity, and this Earth's gravity, there is an escape speed. We have to reach to that speed to reach to certain orbit, and from that orbit we have to accelerate this much. So the whatever the satellite aiming to go to edge of the solar system need to carry tremendous fuel and keep using a rocket engine to keep going to reach to that edge, and that's impossible with the current science. Okay, if we can accelerate to the comet speed like 1268 Mach, this speed, okay, we need a comet speed to reach. So if we don't, what's happened is the sun, you keep flying and it gets slower and slower and slower by gravity and eventually stop. Okay, without a fuel, it stopped and it's come back just like comet and go around the sun at a tremendous speed and go back. And here's the edge of the universe. You never reach to the edge of the universe. What does it mean? Okay, the Escape velocity is hard enough for the Earth. Now we're talking about escape velocity for the Sun. So what we can tell from this simple calculation is there is not enough energy to fly to the edge of the solar system without adding tremendous energy, which is impossible for the current human science. Carrying that much fuel is impossible. I mean, it may take 10 years to fly there, but 10 years you have to keep burning the rocket fuel. And where does fuel come from? There's no way the current technology can do this. So it's correct to think that the human is trapped in the solar system for a long time. The human doesn't have a science to get out of the solar system. Human cannot even reach to the edge of the solar system. There's no way you can go there without huge energy and fuel tank. Okay, so maybe your homework, think about how far can you fly away from the sun without the current largest rocket, with the current largest rocket. Well, here's the sun. This is the edge, 9 billion miles away. I would say you can't even reach to Uranus, which is 2.6 billion miles away. I don't think we have enough technology to fly that far because of the energy requirement. Okay? So we need enough kinetic energy to fly over there. If we don't have enough, then we have to keep burning the fuel in the rocket engine to keep going. Otherwise, sun is going to pull back, just like a comet. There is a reason why comet come back. The sun is pulling back all the way from the edge of the solar system, all the way, and it's shooted back. Okay? So it's safe to say that probably you can't even go to Uranus. If somebody said, yeah, we can reach to Uranus, that's a BS, okay? You think about the amount of energy. It's simple calculation. It's a physics. So this is why you have to learn physics, to know what is fact and what is BS. Okay? So I hope you enjoyed this video, and we have more interesting videos. Please check it out. If you like, please click subscribe. Thank you.